Hey, Papa again. We've been talking about sedimentary rocks that contain quartz and potassium feldspar mostly. And it's true that most sedimentary rocks do contain quartz and or potassium feldspar in some, combination. We found out that there's conglomerate, which tells you that there was an ancient river there in which you have a matrix of quartz and potassium feldspar, mud with or sandstone. It can be sand with large hunks of smoothed off rock in it. And we talked about regular old sandstone, which is sand-sized particles all glued together with iron or calcium. And if you find sandstone, you're talking about ancient beach area or ancient sand dunes or a sandy coastal plain area. Now we're going to talk about siltstone, which is like made of grains of sand-sized particles that are smaller than sand-sized particles, but bigger than mud-sized particles. And siltstone is most likely, I believe it's a combination of sand and potassium feldspar mixed together. Because most of your clay comes from feldspar. And most of your sand, comes from sand-sized quartz particles. If you put them together, you get something in between, which is siltstone. Here's an example of siltstone. Okay. Interestingly enough, when this siltstone first came out of the ground, this part was green because it's full of iron. But as it's been exposed to air, it's kind of oxidizing and turning kind of a tan color. Okay, so this is siltstone. Look at this siltstone. Isn't that cool? You can tell you had repeating deposition events of two kinds that were repeated. So you get, you've got finer material in here and maybe more siltstone material here. This could be clay. Isn't that a cool? It's a sedimentary rock. Where do you find siltstone? I am not really super up on siltstone, except I know this. If you go to Great Smoky Mountains National Park, cross over the mountains going north, and just before you get to, when you get about to the Great Smoky Mountains National Park headquarters, which is south of Gatlinburg, pull over on your right, and you can walk along the creeks and see tons and tons of this, and it's called Pigeon Siltstone. Pigeon Siltstone. And you can also go into Gatlinburg and there's a grocery store. Big G or something like that. If you turn right and go a few miles, look on your left, there's IGA grocery store or something. Anyway, there's a cutbank right there that's just loaded with this Pigeon Siltstone. Pigeon Siltstone. Made of combination of quartz and potassium feldspar. Particle size smaller than quartz, smaller than sand, larger than mud. And how did this pigeon siltstone form? This pigeon siltstone formed when Rodinia supercontinent, we'll talk about supercontinents later, was rifting apart. The land crust stretched because it was rifting apart, and then popped and broke into two pieces. In between was a huge, deep graben, and material flooded into that graben or basin. And at first it flowed in slowly because the basin wasn't deep. This is when the basin was a baby basin and it was just formed. It flowed in slowly and filled up this basin with all this silt-sized material. It was flowing in. If it had been flowing in super fast, it would have brought in sand. If it had flowed in super slow, it would have brought in mud. It was flowing medium, so it brought in all this silt. All this silt piled up. And then as the graben got wider and deeper, and the distance from the bottom of the graben to the top of the crust, the land was higher, the material began to wash in more quickly, and it became turbidite material. The turbidite sandstone or gray wacky that we you've seen also, which is the mud sand matrix with the large, rough-sided particles of quartz and feldspar in it. So that's siltstone, the Pigeon Siltstone. You can also see something in Great Smoky Mountain National Park called the Metcalf phyllite. Well, Metcalf phyllite is pigeon siltstone that's been put under metamorphic pressure, pushing and shoving. So that's a great place to go to see siltstone and its metamorphic equivalent, which is phyllite. All right, bye-bye.